that molecule, it's got so many different qualities that make it potentially the most useful nutrient. It's not really talked about like a nutrient per se, but you could easily describe anthocyanins as though they were a vitamin. You look at vitamin E and you look at the role that vitamin E plays in the body. Yeah, we have an RDA for it, right? We have a certain amount that every individual has to receive over the course of whether it's a day or two. You could make that argument for anthocyanins because of their unique ability to affect so many areas of our physiology, how compatible they are with us. I mean, they're never an antigen, so they never cause, any type of allergenic reaction. They're very compatible with our physiology, very safe even at high levels, and they affect such critical areas of a cell, the organelles in a cell, and then collectively have just enormous ability to influence things as important as our blood-brain barrier. So you look at those qualities, and then secondary to that, you look at the areas of our physiology that benefit from regular anthocyanin consumption and availability, and just so many areas of our nervous system, right? The brain, the eyes, as well as other areas. You look at the renal system, how the blood and hemodynamics in our blood change, the reproductive system, obviously our liver. There's just, and cardiovascular health is clearly influenced by anthocyanins. So you've got the mechanism in place. We've got so much research now illustrating the benefits of anthocyanin consumption in larger quantities as opposed to lower quantities. It's really just a remarkable molecule. Again, I spent around 3 or 4 years of my life studying that in my PhD work, some of which I'll share with you a little later. But this molecule has just, amongst all the polyphenols and all of the phytonutrients that are out there, you could make an argument that anthocyanins are number one in their ability to offer optimal human health when they're included as part of a regular diet. And these are some of those mechanisms that offer neuroprotective effects. We know that anthocyanins, prevent small, dense LDLs from being oxidized, and that's really one of the main components to heart disease. We'll talk a little bit later today around why it is anthocyanins are protective against obesity and diabetes. Again, the antioxidant properties are there. It's just a very, very fascinating molecule, and these just really get to the heart of those mechanisms and the ability to change the etiology of different diseases. So now let's really talk about where they're found and I'll try to provide some clarity around the richest sources. Now, when we say the richest source overall, I think black currants would be probably my number one choice overall, because as you can see, black currants have an incredibly dark, almost black. They're really a very, very dark purple, but they're described as black because of how concentrated anthocyanins are in the skin of the black currant. Now, of course, black currants aren't really considered to be a common fruit, so that's why they're often left off some of these charts, and they have less sweetness, a really, really strong flavor. So that's another reason why they're not consumed as regularly as some other fruits. You could say the same thing about elderberries, which elderberries have incredible medicinal use, but they are really high in their alkaloids, so they can't be consumed raw. They need to be cooked thoroughly to address some of that alkaloid content. They're not as sweet as other fruits. So again, leaving some of those more esoteric fruits off of the list, and you get down to really your more common berries as being your most concentrated and commonly consumed foods. And blueberries are, again, that's the fruit that when I was working at the University of Maine, I was working with like the Tufts University Center on Aging and Disease Prevention. This is the blueberry is the one that we focused on because it was the food in North America that had the highest anthocyanin content and was also widely available, could be consumed in a wide variety of fashions, whether that be raw, juiced, cooked to some extent, although heating does have an effect on anthocyanins. It can reduce the content. But, blueberries, bilberries, blackberries, would be the three, and pomegranates are becoming a little more common. But those would be the fruits that I would really say offer the greatest return and have the easiest, path to using. This is a chart that I really like that's in Advanced Nutrition from 2020 because it looks at popular fruit consumed and has what I consider to be, really accurate anthocyanin levels as have been confirmed through multiple analyses. So you can see here that blueberries are, at the top of the list, along with blackberries. And then, after that, you get into the darker plums and things like that. So again, I'm really showing you some of these different sources of anthocyanin content to reflect why sometimes you hear conflicting reports about what fruit is absolutely the best source of anthocyanins. You can include some lesser available, kind of more unique fruits or berries like elderberries and black currants, and absolutely I'm in agreement, those are incredible sources of anthocyanins. But when you look at the fruits that are more commonly available, very easy to consume, in a variety of ways, blueberries, both low bush and high bush, are really your best choices. And the area of our physiology, if we get down to this on the micro level, that's most important to protect with antioxidants, and where the research has clearly shown anthocyanins are an absolute superstar, it's the mitochondria. The reason that our brains change as we age, often in the wrong direction, right? Loss of cognitive function or impairment, not even getting into some of the neurodegenerative issues, it's loss of mitochondrial function. I mean, that, in conjunction with more senescent cells and, impaired circulation, right? Less blood flow to areas of the brain. You put these, 4 or 5 changes together as an individual ages, and it's really the perfect storm for the brain. But the loss of mitochondrial function, it's front and center. And mitochondria, in addition to just playing an important role in brain health as we age, we know that mitochondrial dysfunction is at the core of so many diseases, a lot of which are neurological or neurodegenerative, but it's also really a big part of cancer. Cancer could easily be looked at as a chronic disease. Often it's not portrayed that way. But it's really clear that mitochondrial dysfunction is a huge component to cancer. So it's a critical area of our physiology that often doesn't receive enough attention. And it is, to restate this, it's the reason why antioxidant rich fruits and vegetables, and anthocyanins in particular, are so protective. The reason our mitochondria are often impaired as we get older is that they're constantly exposed to toxins from our diet or from our gut microbiome. For instance, we know that blue-green algae contaminated foods and water that people are often exposed to, whether they're drinking it or recreating on it, boating, water skiing, swimming, eating the fish from blue-green algae contaminated water. It's a huge cause of Parkinson's and ALS because of the way those toxins in that blue-green algae affect someone over the course of their lifespan. A lot of individuals have a loss of mitochondrial health because of really such high levels of dietary carbohydrates, simple sugars, and becoming so dependent on that as their primary source of metabolic fuel. So they lose that metabolic flexibility, and this is really important with neurological health. And then, of course, there's other toxins as well. The artificial sweeteners really can take their toll on the mitochondria. Heavy metals, of course, lead, really being a big cause of mitochondrial myopathies. So the mitochondria are constantly insulted and are really receiving the brunt of a modern lifestyle and the environmental components to that. And so protecting those mitochondria is a big part of trying to provide an individual with an improved outcome or an optimal quality of life. And eventually, the loss of mitochondrial function, which you see at the very center of this slide, causes neuronal death. And then you just can't take care of any area of cellular physiology. You can't repair the DNA that's important for transcription. You can't repair that DNA without adequate ATP production, and that ATP, of course, has to come from the mitochondria. So it's a chain reaction, and it's not just limited to neurological health. It's a big part of cardiovascular health. Cardiac tissue requires high levels of ATP to function properly, and we know that in a lot of different versions of cardiovascular disease, there is impaired metabolism, ATP production, and the mitochondria of cardiac tissue is impaired. The same thing with our liver as well. So look, it's critical. We focus on the brain most often when we talk about the ability for antioxidant-rich foods to improve life, to improve outcomes, to offer disease protection, because we've got this growing body of clinical evidence that clearly illustrates how that ratio of oxidants to antioxidants, or oxidative stress to antioxidants in our diet and what our bodies produce, that balance is now more than ever being tipped in favor of oxidative stress, less and less protection being provided by a diet which is really it's not containing the levels of antioxidants that our ancestors would have consumed. And you don't have to go back to the Stone Age, you don't have to go back to a Paleolithic time to find marked differences in the levels of antioxidants that are consumed now in comparison to our ancestors. 200 years ago, the levels of vegetables and minimally processed plants and berries was much, much higher than it is now. Now people eat just so much more processed, heavily refined food that is absent. It's just void of molecules such as anthocyanins and polyphenols and these incredibly protective and dynamic molecules. They're, for a large percentage of the populations now living in an industrialized, heavily processed world, food-wise, they're just absent. And so because of that, our brains are the organ which are clearly suffering at an accelerated rate. And there's, again, just an amazing amount of clinical research that illustrates that. So it's that ratio. Alzheimer's disease, of course, has an inflammatory component. It has a very, very high level of oxidative stress at the core of the disease, with the inflammation and the amyloid tangles that arise as a result of that oxidative stress. The initiation and activation of the NFKB, nuclear factor kappa B, and how that causes those microglial tangles and damage. But as you can see on the far right of this slide, in animal studies, and I'm going to share some really amazing research in a moment that goes back to 1999, blueberries and anthocyanins in general, anthocyanin-rich foods, have the ability to arrest or really ameliorate that reactive oxygen species formation that accelerates the formation of those amyloid tangles and those plaques, which are, that's really the stage of Alzheimer's where a patient tends to turn the corner for the worst. So there's that component, that oxidative stress component, where anthocyanins are bar none the most potent molecules out there to help stop the propagation of many diseases. So this is that early study that I was referring to. And James Joseph, the late James Joseph, who was absolutely a pioneer in the discovery of anthocyanins, in research and initial investigations as to how foods rich in anthocyanins offered protection to both animals and humans. And so his research started in the late 80s, at Tufts University. He was a mentor to much of my PhD work. I taught with Dr. Joseph, for the Center for Mind Body Medicine out of Washington, D.C. And he shared his research with me while I was in the early stages of my PhD work. And these 4 slides, I think, are very powerful because they will show you what the difference in dendritic branching looks like in a mouse that's around 18 months old, and that's equivalent to a human being in their 80s. Okay, so what Dr. Joseph did is he fed mice and other animals as well, and then I did some of this with humans and looked at how that blueberry consumption influenced various areas of a woman's health. But what Dr. Joseph did initially is he fed mice blueberries at around 3% of their diet, which would be like an average adult human consuming around 100 grams per day when you look at it that way. So 3% of a mouse's diet containing blueberries versus other plants, or a controlled diet which didn't have any anthocyanin content or any unique plant. And what he showed was that if you look at the neuron, here's a neuron, and you can see all the branches coming out of the neuron. Those are the dendrites, right? And the more branched a neuron can be, in essence, the better that neuron will function. And of course, our brains are the collective sum, or in total, our brains will function like the individual unit of our brain, the neuron function. So we're really going to be, at the end, a brain's going to function at the same level of the individual unit that makes those, that organ up. So here's a neuron and all the dendrites with an animal that did not receive the blueberries, and then look at how highly branched. You can see all the nodules that are present on the dendrites of this mouse, which received blueberries at 3% of its diet. Again, that's like you or I eating about 100 grams or a little over a cup a day. And you can look at this more closely. We take a look at the individual dendrite, and you can see those nodules. Again, here's a mouse that didn't receive blueberries, and no blueberries in its diet. And here's a mouse that received the blueberries at 3%, and much higher concentration of those nodules on a dendrite, which ultimately can form branches for other dendrites that are going to be more far-reaching and are going to allow that neuron to communicate more effectively with other neurons, and in the case of neuromuscular junction, stimulate greater neuromuscular coordination. So again, we have so many different ways to look at anthocyanins and their ability to protect our health. We can look at this. We can also look at the mitochondria, like I just mentioned. And it's not strictly limited to neurological health. This is a great paper that's in the journal Molecules. It's a very recent one from earlier this year, and it looks at how anthocyanins have the ability to prevent both obesity and type 2 diabetes or insulin resistance. And again, there's different mechanisms here, from the oxidative stress component to something that's very different, which is the effect that anthocyanins have on the microbiome. The microbiome obviously has an enormous role in the development of insulin resistance. And when you look at the families of bacteria, which are clearly associated with more insulin sensitivity, which is, again, less insulin resistance, you have Akkermansia, you can see here, second from the bottom, as being one of those families of bacteria with an incredible body of clinical evidence supporting its role as a protective molecule. And of course, Clostridium being a high risk family of bacteria, meaning that it increases individuals' risk for developing insulin resistance and subsequently obesity. Well, dietary anthocyanins, this has been shown with blueberries, blackberries, cranberries at a higher rate than even the others, and raspberries. All four of those families of berries have been shown to decrease Clostridium levels and to increase Akkermansia as well as Bifidobacter populations in the guts of individuals that have been put on various levels of berries in their diet. It's also been shown with animals, and that has incredible effects. Number one is when you increase those families of bacteria, especially Bifidobacter and Akkermansia, you immediately have, as a result, a better gut barrier, which in turn is going to let less endotoxins and lipopolysaccharides into circulation. That's going to be very protective. And then, of course, you have, by having more of those families of bacteria, you're going to have higher levels of short-chain fatty acids, which are anti-inflammatory and have been shown to decrease adipose tissue levels and the formation of adipose tissue, even in animals and humans, which have similar levels of glycemic control. So a lot of different mechanisms at work here, from the microbiome to the antioxidant, less oxidative stress, and the effects there. But again, it's not just neurological protection, it's protection against obesity, diabetes, heart disease, and here ulcerative colitis, because of how anti-inflammatory anthocyanins and berries are against that, that really debilitating gut wall inflammation and autoimmune issue that arises with ulcerative colitis and Crohn's disease. So just so many different reasons to make anthocyanin-rich berries, fruits, vegetables a part of our patient's diet one way or another. And this is a slide, this is one of my favorites, because it shows you the different molecules and mechanisms that anthocyanins and polyphenols, this is specific to blueberries, and the diseases that have been clearly shown to have risk reductions occur when higher levels of blueberries are in the diet, animal and human studies collectively here. So you can see it's a much longer list of chronic diseases where risk reduction has been illustrated. But cardiovascular disease is a big one. And a lot of that has to do with the ability for blueberries to protect those small, dense LDLs from that initial oxidation that allows the LDLs to infiltrate the artery lining, but many others here. So this is a really good summary slide. It's a 2018 paper in that International Journal of Molecular Science.